Hello, this will be lesson 3.2, rate of change and slope. So let's get started. Okay, as I said, this will be about rate of change and slope. The standards will be I can calculate rates of change and I can calculate the slope of a line using graphs. And our standard is from F4, the one from the previous standard or the previous lesson as well. Construct a function to model a linear relationship between two quantities. Determine their rate of change and initial value of the function from a description of a relationship or from two xy values, including reading these from a table and from a graph. And we started doing that in our last lesson, so that should be a little bit more familiar with you today. Interpret the rate of change and initial value of a linear function in terms of the situation that it models and in terms of its graph or a table of values. We're going to be talking more about that today. I'm going to minimize myself here and let's continue. Okay, I am a linear equation. I rise when you run. So this will make more sense by the end of the lesson, hopefully. We need to talk about a definition, the rate of change. What is the rate of change? A rate of change is a ratio of the amount of change in the dependent variable, that's your output, right? That's your y value, to the amount of change in the independent variable, that's your x value, that's your input. So rate of change is also equal to slope, which we'll be talking more about in this lesson. So here's Spider-Man looking at another Spider-Man saying slope, rate of change. So they are the same thing. So how do we find rate of change with numbers? Here's an example. Eve keeps a record of the number of lawns she has mowed and the money she has earned. Tell whether the rates of change are constant or variable. What does variable mean? Changing, right? Constant stays the same, variable changes. So here is an example. We have a table that we've made from this word problem. So the number of lawns is going to be our x value. That's our input, our independent variable. And the amount she earned is our dependent variable. That's our output. So if she mows more lawns, she'll make more money. So that's why amount earned is dependent upon the lawns that she mows. So you see we have day 1, day 2, day 3, and day 4 there, and then the amount that she earns each day. So figure out what X stands for, that's your step 1, and what Y stands for. We've told you, or I've told you. However, it's not always going to be the case. You're going to have to figure out what X is. You're going to have to figure out what Y is. So we're going to say let X equal the number of lawns and let Y equal the amount that is earned. Okay, so X is your independent variable, Y is your dependent variable, X is your input, Y is your output. There's our table again. Step 2 then is to find the rate of change. So here's our formula over on the right there. Rate of change is equal to y2 minus y1 over x2 minus x1. And get very familiar with this equation because we're going to be saying it over and over and over again. You're going to be using it a lot. So we want to find the rate of change from day 1 to day 2. So we're going to come over here and we're going to label our y2 and our y1. I strongly suggest labeling your numbers because it gets very confusing if you don't. So we're going to call this y2. It doesn't matter which one you call y2, but once you call it y2, the one that goes with it, its partner, has to be the x2. If I call this one then y1, this one would be its partner, would be x1. Notice in the formula over here, the y2 always has to be above the x2. And the y1 always has to be above the x1. They have to stay together. This is a big error kids make a lot when they're doing this. Okay. Now, how do we figure this out? Well, we have our y2 and our x2 and our y1 and our x1. We just plug it into our formula that you're going to have to memorize. So the 45 is coming from our y2. The 15 is coming from our y1. And notice how the 3 is my x2 right below my y2. And my 1 is my value right below the y1. Okay, so now we just do the math calculations. So 45 minus 15 is equal to 30, and 3 minus 1 is equal to 2. And then we do 30 divided by 2, which is equal to 15. So that is our rate of change, 15. Now we have to do the same thing for day 2 to day 3. So I have to change my x2s and my y2s and all that stuff. So I'm going to erase this because we're not using day 1 anymore. And I'm going to change day 2's numbers. So this will become my x1. This will become my y1. This will become my x2. And this one will become my y2. And then I can get rid of these now. And we put them into the formula. So y2 minus y1, 90 minus 45 over x2 minus x1, 6 minus 3. Then we do the math. 90 minus 45 is 45. 6 minus 3 is 3. And then my final step is to divide 45 by 3. When I divide 45 by 3, I get 15. So that is my rate of change from day 2 to day 3. And finally, I have to do my rate of change from day 3, from day 3, move there, day 3 to day 4. Typo there. So if I'm doing my rate of change now, I've got to erase and change my numbers here. So now I've got this being x1 and this being y1. This one becomes y2 and above it becomes x2. Plug into my formula y2 minus y1 over x2 minus x1. I plug in 120 minus 90 on the top and 8 minus 6 on the bottom. Again, notice that I have to keep the buddies together. 120 has to be paired with the 8 and 90 has to be paired with the 6. This gets more confusing when we do graphing, so be sure that you keep that straight. Then I figure out the math, 190 or 120 minus 90. And I do 8 minus 6, and I get 30 over 2. I divide, and I get 15 as my rate of change. Now, notice that the rates of change, or the rate of change, is constant. So there is a constant of proportionality equal to 15. Our last lesson talked about constants of proportionality. So since every day the same rate is applied, then we have a constant. So the relationship is considered proportional when you have a constant of proportionality. Proportionality. So it's proportional. And the equation for this relationship is y equals 15x. Remember what it was yesterday? Y equals kx. And k is your constant of proportionality. So that's why y equals 15x is our equation. Okay, ready to try another one? The table shows the approximate height of a football after it is kicked. Tell whether the rates of change are constant or variable. Constant meaning the same, variable meaning different. So we have to do, this chart is set up a little differently. We have to figure out what our x is and what our y is. The chart tells us, but it's not always going to do that. So our input variable is time, that's our x. And our output variable is y, that's the height of the football. So we know that as we kick the football, it's going to go higher, 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 and then it's going to start falling back to the ground. So step 2 then is to find the rate of change. That's between each interval. There's our formula, y2 minus y1 over x2 minus x1. The rate of change from 0 seconds to 0.5, so we're going to take the first interval here. We're going to label our y2s and our y1s. Let's make this y2, and that would make this one x2. This would become y1, and this would be x1. And note that it doesn't matter which one we choose for x2 and y2. They just have to stay together. We could have switched it and done the other way. The reason I'm not is because then I'd end up with 2 negatives, and then I'd have to remember to divide the 2 negatives, make a positive and all that. So that's why I'm going this direction. So y2 is 18, x2 is 0.5. Then I just put them into the formula. 18 minus 0, y2 minus y1 over x2, 0.5 minus x1, 0. Do the math, I get 18 over 0.5. If I divide 18 by 0.5, I get 36, and that is my rate of change from the interval 0 seconds to 0.5 seconds. Okay, next I do the rate of change from 0.5 to 1.5. It means now I'm going to erase my x1 and y1 up here. I'm going to change which one's my y1 and which one's my y2. This is now going to be my new y2. This is my new y1. This is my y1 here. Oops, my y2. This is my x2. See, it's easy to mess up. y1 and x1. Okay, make sure I got that right. Yes, I do. Then we plug it into our formula and we do y2, 31 minus 18 minus y1. And then the x2 minus x1, 1.5 over 0.5. Do the math. You get 13 over 1. That means that equals 13. So that is your rate of change for the second interval. Then you do the rate of change for the third interval. So my third interval is going to be from 1.5 to 2. I am therefore going to erase these and my little numbers here. Now my y2 becomes this one. My x2 becomes this one. My y1 becomes this one. And my x1 becomes this one. It's a very good idea, again, as I said before, to write these little y1s and y2s, x1s and x2s next to the number, so you don't have any chance of getting messed up. Plug them into the formula, y2 minus y1 over x2 minus x1, 26 minus 31, and 2 minus 1.5. And it's okay, you know you're going to get a negative, right? 26 minus 31 is going to give you a negative what? 5, right? And on the bottom, you're going to get 0.5. You divide 0.5 or negative 5 by 0.5 and you get negative 10. Why is that? Well, think about a football. You start at 0, you kick it, as time gets more and more and more, the football goes up, 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 up. And then gravity starts to bring it back down. So it's going to go in the negative direction. Here's your positive direction. Here's your negative direction. So that negative 10 is the rate of change for that third interval of time. Now notice that our rate of change is not the same. So the rates of change are not the same. So there is no constant of proportionality. The relationship is not proportional. It is not a line. We just drew it, right? I just erased it, but we just drew it. It was like this, right? Something like that. It is not a proportional relationship. Okay, it's your turn to give this a try. We'll see you back in a moment. Okay, welcome back. Now we're going to use graphs to find our rate of change. This graph on the right that I'm bringing up here shows the distance that Nathan bicycles over time. What is Nathan's rate of change? So instead of a table, we have a graph. Again, the X value is on the horizontal and the Y value is on the vertical. And then you have to look at your numbers here. And you can see that what does each line represent? 5, right? 5, 10, 15, 20, 25, 30, 35, 40. There's a little bit off, isn't it? Yeah, my computer made it off a little. So this is 10 right here. 15, this is 20 here. So try to keep your numbers by the line, super important. 30 is here, 35, this is 40 right here. This then is 45. I'm just going to write over it because the computer messed it up. And then this is 50 right here. See if I can read. Hopefully you can read that. This is 55 here. And then this line here, you can't read that. This is 60 right here. So I'll get rid of the 55 because that's crunching it out a little bit. So, and so that's 60. This is 50. And then we can get rid of the, well, we leave the 45 in there too. Okay, so there's the actual real spot. And remember when you're making these graphs at home and stuff, you're going to want to make sure your numbers are on the lines and not the spaces. So again, the rate of change is y2 minus y1 over x2 minus x1, which is the same as saying the change in the distance y divided by the change in the time x. Another way of writing change in mathematical language is to draw a triangle. This means change. Change in distance over change in time. Okay, so let's figure it out. Step 1 is to decide what x and y equals. We already know what the graph is showing us, so let's put these points, let's plot these points. This point is 115 because let's see how that works. This is at 1, and I go up to here, that's 15. This is at 230, so this is supposed to be on the line here, 2, and then it goes to 30. Remember, 30 is a little off center there. In fact, all my numbers just got erased. Maybe I can redo it. No. And then the next line is 345. So remember where our 45 is. If this is our 30, this is our 40 right here. So 45 is this one here. That's 45, not 40. And that is 3. And then this one then is going to, the numbers are going to be off. This is 45, this is 50. Right. 40, what is this? This is 45, 50, this is 55, this is going to be 60. So our final point there is 460. Now we're going to figure out our rate of change from 1 hour to 2 hours. That's our first interval that we're going to choose. So now we have to figure out our y2 and our y1, right? So this is our y2. This is our x2. This is our y1. And this is our x1. It's a really good idea to write those numbers by there. So then we do y2 minus y1, 30 minus 15 over x2 minus x1, 2 minus 1. Do the math, you get 15 over 1. So the rate of change is 15 miles per hour. Now, rate of change from 1 hour to 4 hours. Okay, I'm going to erase some of these extra lines that we don't really need in here. I will try to keep the 60 there. So now we have 1 hour, that's this point here. In fact, let me erase this and circle that. 1 hour to 4 hours. We're going to use these 2 points and find the rate of change between those 2 points. So we have to label our x1 and our y1 and all that. So this is going to be my, I'll just change colors here. This is going to be my my y2 and my x2. This will be my y1 and my x1. Plug them into the formula, y2 minus y1, 60 minus 15 over x2 minus x1, 4 minus 1, leaves us with 45 over 3. Divide that out, you get 15 miles per hour. And then we are going to do the rate of change from 2 hours to 4 hours. We're going to keep the 4, but now we're going to change to 2 hours. So we're going to go this one right here. So we can still use that as y2 and x2, but this is going to become our y1, and this will become our x1. Plug them into the formula, 30 or 60 minus 30 on the top, and 4 minus 2 on the bottom. Do the math, you get 30 over 2, which is equal to 15 miles per hour. A graph of a proportional relationship always goes through the origin. Remember I said that in a previous lesson. Here's the origin, 0, 0 is the origin. So the graph shows a proportional relationship between time and distance. So we know it's proportional. We didn't have to actually go through all of that calculation, because all we had to do is look at the graph and see that it goes through the point 0, 0. However, you still need to do the calculations because you're going to be doing a lot of this. So yes, you do have to do the calculations. Okay. Let's do some more about proportional relationships. Does a proportional relationship have a constant rate of change? What did we say about that? Yes, right? You have to have a constant rate of change in order for the relationship to be proportional. Does it matter what interval you use when you find the rate of change of a proportional relationship? No. In a proportional relationship, the rate of change is constant. So notice how only in a proportional relationship does it not matter what two intervals you use, okay? You only in a proportional relationship will the interval rate of change be constant. When the rate of change is constant, any segment of its graph has the same steepness. This steepness is called slope. More about that in a few minutes. Now it'll be your turn, and I'll see you back in a moment. Welcome back. Now we're going to talk about slope. Slope is something we're going to be talking about for many months, so it's very important to understand what slope is. Slope can be uphill and are represented by positive numbers. So here's your biker, and slope, by the way, goes from left to right. And you're looking at this linear line here, this linear equation. It goes from left to right. So this guy's going uphill. Uphill is a positive slope. Slopes can also be downhill, represented by negative numbers. Now you see the biker going downhill. That is a negative slope. The steepness of the uphill or the downhill is called slope, and the steepness is given a number. So here's 3 different slopes. Which one would be the steepest one to bike up? Yeah, A, right? A would be the steepest. Which one would be the least steep? Right, C. So which line has the steepest slope? Line A has the steepest slope because it is hardest to bike up. And line C would have the least steep slope because it would be the easiest to bike up. Take a look at it some more. Here's our 3 slopes again. Which line would be given the largest number for its slope? A, B, or C? Yes, A, because it is the steepest. Line A would have the highest number because it is the steepest slope. So let's assign it the number 5. Okay, which line would be given the smallest number for its slope? Right, line C, because it is the least slopiest. Not sloppiest, but slopiest. Line C would have the lowest number because it has the least steep slope. I wonder if that's a tongue twister. Least steep slope, least steep. It is. Try saying least steep slope fast 3 times. Good luck on even saying it twice. So we're going to give line C a 1. And then line B is going to be a number somewhere between 1 and 5, correct? Yes, so line B would be between it, so we're going to give it the number 3. Okay, so far so good about slope. Let's move on. What is the slope of this line? Does that have a number? Is it a slope at all? That's a flat line, isn't it? So that slope would be 0. A horizontal line has no slope. It does not go uphill. It does not go downhill. It is flat. There is no steepness. The slope equals 0. Slope equals 0. What about the slope of this line? What number would you give that? What number? 10, 11, 12, 13, 14, 15, 16. What number would you give it? Well, we call that undefined. The vertical line has a slope so steep that a number cannot be assigned to it. The slope is called undefined. So just remember that with horizontal and vertical lines. More about slope. Now we have some slopes that are going downhill. Remember about slopes that go downhill, the number assigned to them is going to be, right, negative. Which line would be given the most negative number? Most negative. Right, A, because it's the steepest. Line A would have the most negative number because it has the steepest downhill slope. We'll give it a number of -6. Which line would be given the least negative number for its slope? I would bet C, because that one is not going very much downhill. It's not very steep. Line C would have the least negative number because it has the smallest steepness. So let's give it a -1. And then B would be somewhere in between -1 and -6. So we would give it a -4. Okay. Let's talk about a few more ways to explain slope. Slope is a constant rate of change between all points. Slope is the steepness of the line that contains all the points in a relationship being analyzed. Slope of a line is the ratio of the change in y values to the corresponding change in x values. Slope is called m in the equation, and it replaces the letter k. So y equals kx and now becomes y equals mx. And from now on, we're going to be referring to it as m. Slope can be found using any of the following formulas. M equals, where have you seen that before? y2 minus y1 over x2 minus x1. That is our rate of change, right? So slope is really a rate of change. Another formula is the change in y over the change in x. Again, the triangle means the word change. And isn't that what we're doing right here? We're finding a change from one y value to another, from one x value to another. It's just another way of saying the same thing. And slope is also rise over run. Rise over run. So we'll talk about that. So it's your turn to answer some questions. Welcome back. Let's start calculating slope now that we know all about it. Okay, here's a graph. Now remember I told you in our last lesson that we were going to start having 4 quadrants, because graphs don't always have only 2 or only have 1 quadrant. They can have 4, right? The coordinate plane is 4 quadrants. By the way, this is quadrant 1. This is called quadrant 2, and they use Roman numerals. This is called quadrant 3. We use Roman numerals. And this is called quadrant 4. So there's 4 quadrants in the coordinate plane. Okay. We're going to use our formula, y2 minus y1 over x2 minus x1. So here is one of the points, and it only requires 2 points on the line in order to find the slope. So this is the point -3, 2. Remember, we do the horizontal first. So this is your x. So this is -1, -2. This is -3. So if I was to draw my line from here to here, that's -3. And then I have to draw across here. What is that number? Well, this is 1, so this is +2. So that's where the -3, 2 comes from. And then we have to figure out the other point. So that's 3, -2. Why is it 3? Well, this is 1, 2, this is 3 right here. Comes down from the 3, and then it goes over and across to here. And this is the point -2. So once you've established your points, you can work your slope. Okay, so now is where it starts getting confusing. You got to make sure you keep your y2s and your y1s clear. We're calling this y2. We're calling this x2. We're calling this y1 and x1. Could you have switched them around and made this y2 and x2 and this y1 and x1? Yes, it does not matter which one you choose for x2 and y2. But once you choose them, you got to keep the buddies together, okay? So y2 minus y1 is 2 minus -2. Don't get tricked on that kind of question. x2 minus x1 is -3 minus 3. So notice how I kept the buddies together. I kept my +2 with my -3, and I kept my -2 with my +3. Okay, so keep those together. Then we just do the math. So what is 2 minus -2? That's the same as 2 plus 2, right? Because two negatives cancel each other out. So that's the same as 4 on top. What's -3 minus 3? Well, that's the same as -3 plus -3. So what is -3 plus -3? -6, right. And then we can reduce it. Divide the top by 2, divide the bottom by 2, and you get 2 over -3. So the slope of that line is 2 over -3, or 2/3, -2/3. Why is it negative? Because it's going downhill. Did you notice that this line goes downhill? If I'm a biker and I'm biking on this line, I'm going downhill. Whee, there's me. There's my hair flying in the wind as I ride my bike downhill. It's always fun to ride downhill, isn't it? It's really fun. Wind blows at you and you're going really fast. That's fun. I need a seat. There's my seat. There I am going downhill. So it's a negative number because negative slopes slopes that are going downhill have a negative number. Okay. Now we also said there was a formula called rise over run. Same thing. So how does that work? Well, I better clear my drawings here. Bye-bye, biker. So that is my rise. I'm rising from this point up to this line where this point hits it. Okay, so that's my rise. My rise is 4. I'm going up. Let's count. 1 unit, 2 units, 3 units, 4 units up. That's why my rise is 4. And my run is my horizontal. So that's how far I go from this point all the way to the point. So let's count how many that is. 1, 2, 3, 4, 5, 6. Doesn't that sound vaguely familiar? So my run is -6. Why is it -6? Because when you run to the left, the number is negative. If you were to run the other direction, let me get an arrow here. If you run this way, the number is positive. If you go up, the number is positive. If you go down, the number is negative. So keep that in mind. It goes the same as the way the numbers are labeled on the graph. Okay, notice how my rise and my run, this is my run right here. That's my horizontal change. This is my rise. That's my vertical change. So it's the same formula, just said differently. So my rise is 4 and my run is -6. Reduce that down, I get 2 over -3. Same thing, I just used the graph to show me my slope. You can also say the change in y over the change in x. So the change in y is 4 units. It goes from here to there. And then the change in x is from here to there. So like this distance to that distance. 4, -6. Reduce it down, you get -2/3. Same thing, just a little bit slightly different way of saying the same formula. Notice that any of these ways of finding the slope really mean what I just said, the same thing. How much y changes in relation to x? What is the equation of this linear relationship? Can we figure it out? Of course we can. Y equals mx is our equation, right? And what are we going to plug in for m? M is our slope. We found it 3 different ways. -2/3. And that should be like a negative sign there. Mrs. Claus forgot the negative sign because it goes downhill. So that equation is y equals -2/3. Okay. Let's do some more. The graph on the right, it's going to show in a minute, shows the rate at which water is leaking from a tank. The slope of the line gives the leaking rate in gallons per minute. Find the slope of the line. So first of all, just by looking at the graph, what can we tell? Well, I can tell a few things. I can tell that the slope is going to be positive because the line is going uphill. And I also know that my relationship is going to be proportional because it goes through 0, 0. That means that any 2 points I choose on the line will give me the same rate of change. Those are good things to know. So let's begin. There's our formula, memorize it. Slope is equal to y2 minus y1 over x2 minus x1. M is standing for slope, always and forever. Let's pick our 2 points on our line. And again, you're going to be picking your own points. I picked them for you, but pick numbers that are on a line and on a line. Don't pick some random number or some random point here because you don't know what that number is exactly. Okay? Don't pick that. So pick 2 points that are on grid lines. So 8, 6 is on the grid line. So this is 8, and then it reaches over to 6. And the other point is 4, 3. So 4, and then it goes over here to 3. Now that we have our points, we can decide which is our y2 and our y1. I'm going to make this my y2. So that becomes my x2. This is my y1. And this becomes my x1. Always label them so you don't get messed up. Then we plug them into the formula. So I got 6 minus 3, y2 minus y1 over x2 minus x1. Remember to keep the buddies together. 6 has to stay with 8 because they're a pair. And 3 needs to stay with 4. Calculate my math. 6 minus 3 is 3. 8 minus 4 is 4. My slope is equal to 3/4. That's my rate of change. I can do it also with rise over run. How do I do that? Well, I rise from this dot to the line where the other dot is going to be on. So how much is that rise? Right, that's a rise of 3. How do I know that? Because I went, let's count. Oops, I went 1 unit, 2 units, 3 units, and my run is 1 unit, 2, 3, 4 units. So my run is 4. And notice how they're both positive, because when you go up, the rise is positive, and when you go to the right, the run is positive. So my rise is on top, that's 3, and my run is on the bottom, that's 4. So there's my 3/4 for my slope again. You can also do the change in y over the change in x. The change in y is 3. The change in x is 4. So there you have it. And then, what is the equation for this linear relationship? Remember, it's y equals mx. And we're going to replace m with what we just calculated to be the slope, 3/4. So y equals 3/4 x. What does that mean, and why do I care that I have an equation of a line? Well, I can do a lot with an equation. I'm not always going to want to be graphing things all the time, especially if I have very big numbers. Let's say I wanted to say after 3,000 minutes, how many gallons of water would have leaked out? Well, I can make a graph that goes all the way up to 3,000, but that's a pretty big graph, right? So all I really need to do is plug this 3,000 in for my x, for my input, and calculate the answer to see how many gallons of water would drain out. So it would be 3/4 times 3,000. And that would give me 9,000, because 3 times 3,000 is 9,000. Let me just erase my line here. That would give me 9,000 on top and 4 on the bottom. And then I would divide 9,000 by 4, and that would give me my y value. 2,250. By the way, starting with this unit now, you can use your calculators. 2,250. That would be how many gallons would be lost after 3,000 minutes. So you can see how the equation can be very useful. Okay, you get to try this, finding the slope. Okay, welcome back. Let's continue. Let's focus on our higher order thinking. Ben and Phoebe are finding the slope of a line. Ben chooses 2 points on the line and uses them to find the slope, just like we were doing. Phoebe used 2 different points to find the slope. Did they get the same answer? So they have this line on a graph, maybe going this way, and color here. Ben chooses this point, and then he gets an x and a y value for those points, and he figures out his slope using the formula y2 minus y1 over x2 minus x1. So he picks a y2 and a y1 and an x2 and an x1. This is supposed to be a comma. So those are his 2 points. Then you've got Phoebe, and she says, I don't want to pick those 2 points. So she picks this point on the line and this point on the line. And she says, well, this has the coordinate of such and such, x and y. And this one also has the coordinate of x and y. And she calculates her slope. Did they get the same answer? What do you think? Yes. Why? Because, clear this, the slope of a line is constant. That means that no matter which 2 points you choose on that line, the slope will be the same. That's what slope means. Okay. two lines pass through the origin. What's the origin? Right, 0, 0. The lines have slopes that are opposites. Compare and contrast the lines. Well, let's draw a picture of what it's saying. Okay, and the line is passing through the point 0, 0. So let's say this is point 0, 0 here. 0, that's the origin. The x value is 0, the y value is 0. But then let's say this has a slope of, I don't know, let's pretend like it's the slope of 3. Then the other line is just the opposite. So it's going to go downhill, right? Actually, I want to change that to green. Won't let me. Oh, well. So it's going downhill and it's going through the origin as well. What do we know about that slope? It's going to be -3. Now it's green. It's going to be -3, right? So let's see what we all know. Actually, I think it's going to show us. Let's see. Okay, it shows us that line and that line. And the origin is where? Right here. They cross at the origin. One line has a positive slope and one line has a negative slope. The lines have equal steepness, but in different directions. That means one has maybe a steepness of 1, the other one would have a steepness of -1. One would have a steepness of 3, the other would have a steepness of -3. And the lines will cross at point 0, 0. Okay, next one. What is the slope of the x-axis? What is the slope of the x-axis? You should know this one from our last lesson. Nope, from this lesson. Where's the x-axis? Circle it. That is the x-axis. It's labeled with an X. The x-axis is a horizontal line. It has not got any steepness, right? So it has a slope equal to 0. So any horizontal line has a slope of 0. Oh, we are done. So you can go on to Google Classroom and find your assignment. Please don't skip any of the stuff that I'm giving you because you are going to be using this stuff for several months now and all the way through next year in algebra class and in geometry class and in advanced algebra class and in trigonometry and in pre-calculus. And if you go on to take calculus, you will be using what I'm giving you for all of these years. So please don't skip any of the lessons. So I hope you have a good day. Practice makes perfect. Bye.